Hello everyone, welcome to Project Pro YouTube channel. This is me Simran Anand, and in this video I'm going to be explaining you a really prominent topic of data science, which is recommendation engines and recommendation systems. So you must have heard about the Netflix movie recommendation system, or even the Amazon. While you're shopping, you must have observed that there are recommendations sent to you for the products and services by Amazon. Apart from that, you must have, while listening to songs like on Spotify, you must have also come across the Spotify recommendation system, on which the popular songs which you have, or the similar songs which falling into the same genre, are recommended to you by such recommendation systems. So what exactly are these recommendation systems which are becoming really popular these days in variety of businesses in different domains? So recommendation systems is such a concept of algorithms which are made really prominent by the businesses and leveraged by them in order to maximize their revenue, because the more products or the services are recommended to the users, it is more likely that the users will tune into their products and services, and in such a way the businesses are maximizing their income. So let's get in this video. I'm going to introduce you to the topic of recommendation engine, the types of recommendation system, and also would be delving into the concepts and the terms related to the recommendation system. And at the end, we'll be demonstrating a Python code in order to build a recommendation system. So I'll be showing you that what are the types of recommendation system, be it collaborative based recommendation system or the content based recommendation system. So let's get started. So recommendation engines, basically, they are a set of algorithms which the sole purpose of a recommendation engine is to recommend or suggest users with something they would like or they would tune into. But how exactly is this recommendation system appropriate? There must be some concept or methodology which the recommendation systems should be following, so that they could understand and analyze what exactly are the customers liking. So basically, recommendation engine or recommendation system is a system that helps customers or users discover products or services they may like. It is like a salesman of a company who knows what a customer might like based on their history and preferences. So there are a lot of factors which are to be considered by making recommendations. So these engines basically analyze the customer data. So when I say customer data, you have to understand not only the past purchases made by the customer. Say you are shopping on Amazon, and then the recommendations are sent to you by the system. The similar kinds of products are recommended to you, but on what factors are they recommended? Have you ever thought of that? So the factors could be either the history and your preferences. For example, you must be liking a particular genre of song, or you must be tuning into a particular product, a type of product. Basically, suppose you say you have already bought few types of watches while shopping on Amazon. So similar kinds of watches would be recommended to you by the system in such a way that it would incline or would align with your preferences. So your preferences, which are nothing but your history of purchases, will be studied and analyzed by these recommendation engines. Now you know that these recommendation engines must be using a lot of machine learning algorithms behind. So let us understand what exactly the types of recommendation systems and what are the machine learning algorithms which these recommendation engines are solely based on. So when I talked about the recommendation system, the factors could be your history. Solely, just analyzing the system can just analyze your history or the user's history. But then what if the product which is recommended by the system is something which you have not seen before at all? It is something really new. In such a way, these recommendation engines are helping you to discover new products which are inclining to your interests. So you must have not seen this product already, or you must have not heard about a song already. So in this way, you are discovering new products or new services because the recommendation systems are recommending you some new suggestions. But how likely are the users tuning into these products? Now that would depend on the accuracy of the recommendation systems, with what accuracy the recommendation engine is built. So to understand, there are a variety of concepts and machine learning algorithms you have to look into. So when I was talking about the concept of the purchase, the previous purchase history of the user, not only that, but sometimes what you see is there are two users, user A and user B, which are similar. Now what do you mean by similar users? Similar users are those users which are likely having similar tastes or similar preferences. For example, there are two users, user A and user B. If a product or service is liked by user A or is purchased by user A but not by user B, but user B, whenever he's looking for a similar kind of a product, that product which has not been purchased by user B but has been purchased by user A will be suggested by this system to user B, so that there is a high probability or a high possibility that the user B will also purchase the product which has been purchased by user A, in such a way that we can group the similar customers together. Now you see here, we are basically understanding there's a concept of customer segmentation also, which is being looked into over here in the recommendation system. Because firstly, in order to understand for the system to understand who are their target customers, they have to first study their customer data. Now when I say data, they have to also understand the various factors which could even determine the preferences of the user. Say while making customer segmentation or clustering customers into different clusters or groups, there are various attributes which are taken into account, like the age of the user or the customer, the basically the age, the gender, or the location of the customer, and the number of times the customer has logged in or logged out, and also the rating given by the customer to certain products. These are some of the factors which are taken into consideration while making suggestions to new users. And also you must have seen that there are various websites of companies which ask you to fill survey forms. So with the sole purpose of the survey forms is for them to collect information from you all, so that the users which are of similar wavelength, so that is for example of the similar cluster. So say if you are falling into a particular range of customers, a particular age range, the users which are in the same range, for example, there is a kids range, there are elderly range, then the mid range. So the users of the same category are recommended the similar products, because in that way there will be a higher probability of the customers tuning in. Now you see that the customer segmentation is also coming into picture here before making recommendations to the users. So that is how basically Netflix and other such recommendation engines are also studying and analyzing the data of their users, their customers, so that they could make apt recommendations to them. So it is not that easy to give recommendation to customers by just doing customer segmentation. There would be probability and chances the customer still not will purchase or tune into what has been recommended. So it is always important for us to understand how exactly can we improvise a recommendation engine by making use of certain techniques or algorithms, some mathematical algorithms and machine learning algorithms, which would give us a very good accuracy, so that properly the recommendations could be sent to the users. So let's start with the types of recommendation systems. Now, what is differentiating the different types of recommendation system? When I told by introducing you to this concept, I told you that there are basically two types of recommendation engines, and those are content-based filtering and the collaborative filtering recommendation engine. So recommendation systems are based on two types, which are content-based and collaborative filtering. So these two filtering basically is nothing but you have lot of data, because these recommendation systems, they are having humongous amounts of information collected already. But out of this information, there might be something very irrelevant which has to be removed or filtered out in the feature selection process. So while doing that, whichever features which will help the recommendation engine in order to make a particular decision or an apt recommendation to the user will be taken as an important feature. So that is what is going to be done in the filtering step. So when we say content-based filtering, the main idea here is to suggest items based on a particular item. So basically over here, to put it simple, in content-based filtering, it is only the content of the item, or basic item could be a product, a song, or a service, anything which the user is buying or making purchases. So basically a content or watching also, suppose if you say YouTube, the user's history of watching is something, it also can be considered as an item. So basically there are two entities here, user and the item. So what content-based filtering is analyzing the item, basically, that is the content of the already purchased product or the watched service by the user. So that is what is going to be analyzed in the content-based filtering. This kind of concept will not consider the similar users. Basically, it's not going to take in the user's data, so that is the user's rating or the user's data, and compare similar users. That is going to be happening in collaborative filtering. As you can see, the word collaborative filtering is more likely to do with the collaboration of different users. So that is nothing but is going to analyze or calculate the similarity between two users and then suggest similar users, a product which the system thinks that the user will tune into. But in the other hand, content-based filtering is going to suggest items based on a particular item. So it's going to just take into account the user's preference for a movie using metrics such as ratings, and then use items metadata such as genre, director, description of the movie, cast, crew, etc. So basically, already basically the watching history of the user of a particular movie, that is something that can be considered as into the content based filtering, because the users, a particular user, it's more personalizing the recommendation to only a specific user. It's not taking into consideration how similar the other users are, or not taking any users data, but rather the item data is what is going to be analyzed in content based filtering. On the other hand, when we talk about the collaborative filtering, this filtering recommendation technique depends on finding similar users to a target user. So you have the concept of a target user and other users. So whenever you're recommending something to a target user, you have the recommendation system must also understand whether the target user can easily tune in or make purchases similar to the other users. Now, this concept will make use of the similarity here. So basically, it will leverage the concept of KNN, which is K nearest neighborhood. This is a machine learning algorithm which will come handy in collaborative filtering, because it would depend on finding similar users. Now, how similar the users are will depend, of course, on their preferences. Of course, the preferences, their tastes. These are some of the factors. So these are done to make personalized recommendations, and these recommender systems do not require item metadata like content-based recommendation system, and they rely solely on past user to item interactions to render new recommendations. That is what is done in collaborative filtering. Now let's talk about exactly collaborative filtering. Also, there can be many types of collaborative filtering. So when I told about collaborative filtering, there are subdivisions like item-based collaborative filtering and user-based collaborative filtering. Now, when I tell about item-based, since collaborative filtering, as the word says, it is more to do with how similar two entities are. So when I say item-based collaborative filtering, that is where it is going to, the recommendation system will analyze the similarity, will compute the similarity, which is the cosine similarity score. It can either, you can take any metric, for example, the cosine similarity score, to calculate the similarity distance between two items or two users, to understand how similar they are. Or you could also take other metrics such as the Pearson's correlation coefficient, for say, or you could use other metrics like the Euclidean distance as well. So it would depend on whichever algorithm you use, that kind of metric you could leverage that kind of metric to compute the similarity score between the two movies, or for example the two items. So when I say item based collaborative filtering, two items are going, the similarity between the two items which are already purchased by a user, or already tuned in, or already aligned with the user's interests, those will be considered. Whereas in the user based collaborative filtering, it is the similarity between two users which is taken into account. So that is what in collaborative filtering is done. Now there you have the mathematics you have to be aware of. When I'm talking about the recommendation systems, you have to be aware of matrix, because there are a lot of whatever you have to understand here in the content-based recommendation systems, or the collaborative filtering. There is a concept of matrices which you have to be aware of. So there is a user item matrix, item to item matrix, or a user to user matrix which has to be computed. Now matrix, as we say, it is just matrix is having rows and columns. So basically all the values are going to be stored in the form of matrices in order to simplify the computations. So when I just skim through this code, I'll also will be demonstrating the code as to how the collaborative and the content-based filtering recommendation systems would give us the results. So when I talked about the Spotify song recommendation system, the top, if you just enter the name of a particular song, you see that the top 10 songs similar to the song name you have entered will be recommended to you. Now, how exactly are the top 10 recommendations sent to you? That is by a top K algorithm. So this top K algorithm is a part of the content-based similarity, or the content-based filtering method of the recommendation systems, because that is going to make use of the top K filtering after the metric which may be the cosine similarity or the Euclidean distance is computed. So there is a concept of TF-IDF, by the way, you have to be aware of. TF-IDF is because whenever you're talking about the documents, for example, now documents can be, in our case, it can be tuples, or it can be rows of a data. So basically, a data frame can be split into various data frames, and TF-IDF stands for Term Frequency Inverse Document Frequency. So that is one such technique. Over here, the main purpose of TF-IDF to be applied into our code before building a recommendation system is because strings cannot be fed as it is directly into any machine learning algorithm. So we first compute TF-IDF, that is Term Frequency Inverse Document Frequency, and this TF-IDF is nothing but basically converting your strings into vector format. So that, say you have for example, if you take the example of a movie recommendation system, it is relying on a movie lens data set or a movie data set having data frames like the ratings given by the user to different movies, and also the user CSV file, which is containing all the information pertaining to the user, like the user ID, the location, age of the user, his so and so preferences, and so on. And there is a ratings data frame which is containing the ratings given to different movies. So in order to do that, we need to first compute the term frequency inverse document frequency, because in all these data frames, or say in a particular document, how many times the particular term is repeating, or the frequency of the term, that is going to emphasize the importance of the particular movie or of that particular term in the document. But there are various top words, like there are various filler words like the and these do not contribute much to the meaning of the document, so they have to be not be considered. So TF-IDF is one such good technique which is going to help us to reduce the importance of words that occur frequently in our movie description. Like any movie, say be any movie or a song, they consist of a lot of filler words. Any text document also, they consist of these top words. So those top words or these words have to be removed, basically filtered out in the text pre-processing stage. So while you doing the text pre-processing, TF-IDF is one such concept which comes into picture. So once the IDF vectorizer is created, while you have applied the machine learning model, then you have to calculate the cosine similarity. And the cosine similarity, as you might know in matrices concept, it is nothing but the dot product of two. Suppose A and B are the two vectors. Now, in the concept of recommendation system, everything is in the form of matrices. So be it a user matrix or an item matrix and so on. So when I talk about how similar two users are, A and B, then the similarity score between two users A and B, or two items A and B, is nothing but A dot B divided by magnitude of A into magnitude of B. That is nothing but, this is the concept, that is cos theta. So similarity score over here is cosine similarity is calculated by the cos theta, which is nothing but the cos of the angle of similarity between the two items or two users. And it is independent of the magnitude and also is relatively easy and faster to calculate. As cosine similarity, there are other various metrics also which you can consider. So now, once you have made this TF-IDF vectorizer and then computed this cosine similarity score, then you can make the recommendation. That is, while building your recommendation system, the top 10 elements of the list, top 10 is nothing but the components. These components in the KNN, for example, K nearest neighborhood, you can specify the top K by making use of the top K algorithm. You can specify the value of K. So, for example, if you want the top 10 songs to be played, or the top 10 elements from the list of movies, those top 10 will be recommended to the user, which are very similar to the word or the movie which is already entered by the user into the search box. So whenever the user is looking for something, a product, for example, while shopping, if you're looking for a watch with so and so metadata and so and so description, the top 10 products similar to your watch will be displayed to you. So there are, of course, a lot of benefits and limitations of content-based recommendation as compared to collaborative as well. To put it short, I would say that each of them have their own pros and cons. But then collaborative filtering, it is more to do with the user preferences. So it is more like comparing similar users together. So this is where limitation can come into picture, where the collection of the information from the user might cause privacy concerns. That is one limitation that can happen in collaborative filtering recommendation system. Whereas in the content-based recommendation system, one limitation could be that the quality of the recommendation is dependent on the hand-engineered features and thus requires a good amount of domain knowledge. So when I talk about the domain knowledge or the metadata, a lot of metadata has to be understood for the content-based recommendation system, because it is more personalized to a particular user. You're not comparing similar users here. You do not even need the information of similar users for content-based filtering, because in content-based recommendation system, you're just focusing on your target user, and based on his past purchase history, or basically or the past preferences or the already watched history of the user, you are going to make recommendations to that. So you have to you have to have a domain knowledge for that. So that was all about it, and so that the similar genres of movies or songs can be suggested to the user. So as you can see here, there's a lot of maths involved. To explain everything in one video, it would take a lot of time. So definitely you have to have a good knowledge of matrices over here to understand what are the different similarity scores, the matrix available in order for you to compute. Now let me quickly take you through a particular code of book recommendation system. Basically, you can recommend, so recommendation engine can be either for books, movies, products, services, and so on. Here we have the book recommendation system. The sole idea over here is for you to I want to make you understand how exactly this process and how you can get started with building a recommendation system in Python. So you have to first import the libraries NumPy, Pandas, Seaborn, Matplotlib, and so on. And you have to make use of sklearn. Sklearn or scikit-learn is a machine learning library in Python. So you have to make use of this, and we are making use of k-means cluster here. So the sole purpose of k-means clustering is to group similar customers together, similar users together. So clustering, as the word says, you're going to be, this is a kind of customer segmentation you're doing, wherein the similar customers or users are going to be clustered together. Then followed by the model selection, where the train test split. This is common to any machine learning model when you're building. Then you have to import the min-max scaler, which is part of your normalization step, basically, where you are going to normalize, or we can say you're going to basically scale your input into a particular range of values. So it usually is from 0 to 1. It can also be taking the range as -1 to 1. So min-max scaler, there is standardizers and other normalization techniques like Z-score normalization. So over here, we're making use of min-max scaler for scaling our data within a particular range. So this is how we are importing the data here. This is our overview of the data set I've imported. We have the books data set having the attributes as book ID, the title, author's average rating, and so on. The number of pages and other attributes like publisher, publication dates, and so on. Now, what do you think might be, while doing the feature selection, what can be the irrelevant data features over here that you think can be dropped, and some features which will actually help the recommendation system to make predictions? So you have to understand that in the feature selection process. So now I can say title is one important thing, because that is where you are going to understand whenever the user will enter a particular keyword into the search box. While in the search engines as well, they are making use of recommendation engines. So whenever in the search box the user is entering a particular keyword, keywords play a very important role in retrieving the similar documents, or basically similar kind of movies to the user or books to the user. So that is because the keywords are going to be identified, and as I was explaining you, TF-IDF is the technique we'll be looking into. We can make use of such techniques, so that based on the keyword, the frequency and then the importance can be assigned. So this is the overview of the data. To get the sum of whether our data consists of any null values or not. If it is containing any null values, we have to definitely remove those null values, which are nothing but the missing values, and we can either replace them with something more significant, or we can perform imputations. So on doing this, we have found that there are no null values in our data set. So now that we have we have to find the top 10. So I'm just basically slicing our data set to find only those books with ratings count more than this particular value. All the top, basically getting the top books as rated by the user. Sorry. So as rated by the user, you will get the top 10 books. As you can see here, the average rating is given by the user here, and along with that, these are the different statistical metrics that by making use of the describe command, this is the statistical, basically the features and the attributes which basically these attributes will have. So as you see, count, mean, standard deviation, min, 25%, the quartile values, and the maximum, these are going to be plotted for each and every attribute as such. So this is the EDA, exploratory data analysis, we are going to do to understand the attributes, to study, basically analyze the various attributes of our data set, their shape, and so on. So once we get the top 10 books which are having the highest ratings count, this is going to be plotted here by making use of the SNS, and as a Seaborn library which we have imported in Python. We have made use of that, and then we are making use of the bar plot here to plot or visualize our top 10 movie ratings. The book ratings here, because we are having the book data set, we're making use of the book ratings. book. So once it is done, we have to now get the top 10 authors with most books. Now we have first plotted the 10 books having the top average rating, the top 10 average rating. Now we are going to do plot the 10 books, top 10 books having the authors. So basically the most popular authors are going to be plotted here, the top 10 authors for the books. And as you can see in the x-axis, we have the total number of books, and y-axis the authors. Those are going to be plotted. So this is the top K algorithm, with K being as 10 here. Once that is done, we are going to make another plot to basically, this is a part of the EDA process where we are understanding and making use of data visualization techniques to understand how exactly our data is comprising of attributes and which attributes are important for us. So once this is done, we are then plotting another graph for average rating distribution of all books. So for each of them, I'm making use of this SNS, which is Seaborn library. Once that you have understood the average rating of the data, this is another plot. Basically, this is a scatter plot because as you can see, over here, the data points are scattered in nature. So once this is done, over here, then we can make build a book recommendation engine over here by making use of the sklearn machine learning library. So this is one machine learning library. You have to understand that the machine learning algorithm we have made use in our book recommendation system is a unsupervised technique, which is called as a k-means clustering algorithm, as I've shown you. The sole purpose of that was to cluster similar data points together. So cluster the books which are similar in nature, the items which are similar in nature. As we are clustering them together, this is example of a content-based recommendation system, because nowhere we have used any users data. There is no users information or similarity between the users which is computed. Rather, we have just taken the information of a particular book, analyzed how exactly are how exactly the book's authors are, the top ratings given by the different users. So this is item based content based filtering which we are doing, and then we have made use of the k-means clustering to do that and cluster the similar books together. Once that is done, I'll be just delving into this. While you have done for the pre-processing, you're importing min-max scaler. Min-max scaler is basically to scale your input data. It's a part of the pre-processing step where you are scaling your input data within a particular range. You are doing that with a particular range, having minimum value and a maximum value, and it is 0,1. That is going to be done here. Then the features are going to be, you're making use of the fit transform method of machine learning here, basically to train your model, and then also to transform your the features of your data, basically to transform them into a sparse matrix. Now, what exactly is sparse matrix? Sparse matrix is basically a matrix which is containing mostly zeros. It mostly consists of negligible values, and they mostly are zero values. So you're converting that so that for your machine to understand them, because the machine cannot take strings as it is. You basically have to use fit transform here, because you have to convert the strings into vectors. Once the strings are converted to vectors, you have to then transform them in such a way that they are sparse in nature, and then feed it to your model for training. Once that is done, here I'm making use of nearest neighbors, where n neighbors is set to 6. As I've told in the nearest neighbor algorithm, making use of that in the K after doing the clustering for the customer segmentation part, we are making use of that, and then making use of the K nearest neighbors algorithm here. So nearest neighbor is one such algorithm which is basically, if you specify as the number 6 here, you will see in the output the top 6 similar books or similar genre of books will be recommended as the one which is the user wants. So that is what is good. If you can basically use hyperparameter tuning here anywhere you want. So when you change the value to 10 or 11, similarly 10 or 11, similar kind of book titles will be recommended to the user by the recommendation engine. So algorithm over here is the ball tree algorithm. Then you're fitting the features over here to your model. Model.fit is the method, and then you're fitting the features over here. And after doing that, you're then running your algorithm by defining this function, as you can see on my screen, book recommender followed by the book name. Now this is basically a function which has to be called. This has to be called over here. It is going to return the book list name. So whatever output we are seeing here, the top six book which are being recommended, they are nothing but the book titles, the book names, and book recommender over here is the function which is called, and the parameter or the argument which you're passing over here is the is the one book title. Again, it's one of book titles which the user will be entering. So whenever the user enters Harry Potter and the Half-Blood Prince, the all the six book titles given in the data set which are similar in nature to this particular entered topic or entered title by the user will be recommended to the user. So this is nothing but an example of an item based filtering, because it is nowhere making use of the user. So it is a content based filtering which we have seen. So thank you so much. I hope I have made the content clear of recommendation engine and helped you understand what exactly are recommendation engines and how they can be leveraged. So stay tuned on Project Pro YouTube channel to know more. You can also visit the Project Pro website and get guided videos along with 24/7 customer support. There are 3,000 plus code recipes which are absolutely for free. And also do buy our subscription plan to get access to 250 plus solved end-to-end projects, because these projects are created by top industry experts working in top global tech companies. Stay tuned on Project Pro YouTube channel and do subscribe. Thank you.
Project Pro, the only solution for solved industrial grade projects.